Welcome to the Stat 254 tutorial, Week 7 demo problems. I'm Steve as always. Before we get into the first question, I just want to do a brief review of the standard normal. So there's a very important formula that says Z is equal to x minus mu over sigma. And what this is saying is if we're dealing with a normal distribution that doesn't have mu mean equals 0 and standard deviation sigma equals 1, we must first convert to the standard normal, which is the formula in red above, so we can use our tables. Because the standard normal can have any combination, an infinite number of combinations of different mu's and sigmas, we would have an infinite number of tables that we would need to use. So the standard normal is the one table that we do use, and therefore whenever we're given a problem that has to do with a normal distribution, we have to convert to the standard normal so that mu equals 0, sigma equals 1, using the formula in red, so we can use our tables. What it allows us to do is take the probability of x, which we are saying is a normal random variable that doesn't have mu equals 0 and sigma equal 1, and we can rewrite that as the probability of z being less than or equal to x minus mu over sigma. And this allows us to convert to the standard normal distribution so that we can answer our question. All right, question number 1. It says, suppose that x is a normally distributed random variable that measures the time a kitten spends sleeping in hours with mu equals 14, so that's the mean is 14, and it is known that 90% of all kittens spend no longer than 16.1 hours sleeping. What is sigma? So we want to find what sigma is, so we need a formula for sigma. The formula that we saw a couple slides ago is z equals x minus mu over sigma. We can just rearrange this to get sigma on the left-hand side and see that it's x minus mu over z. Okay. So we know mu is 14. We know x is 16.1. But we don't know what z is. So z is what we need to find. How are we going to do that? Well, it says in the question in the last sentence, or the second to last sentence, it is known that 90% of all kittens spend no longer than 16.1 hours sleeping. So, we know that the probability is 0.9. We need to solve for the little z in the formula. And to do that, we go to our tables. So, when we're given the probability, we look in the middle of the table. We find the closest number to 0.9, and then we find the corresponding z value. So if you look in this table, searching around, you see that the closest number to 0.9 is 0.8997. Okay, so then all we do is we look left and up. We see that z value is 1.2, and then to get the last decimal, we look up. So our z value is 1.28. Okay, let's go back to our formula. So now we know every piece in this formula. So we have that sigma equals x minus mu over z, which is 16.1 minus 14 over 1.28. And we get our final answer that sigma is 1.64. So when you're using the standard normal tables, if you're given the probability, you look in the middle first, and then look left and up to solve for the z value that you want. In the next question, we'll see the reverse. So question number 2. Suppose we select 8 kittens at random. What is the probability that exactly 5 kittens will sleep no more than 15 hours? Like in last week's video, there's something that should jump out at you here, and that is that we have So we're selecting 8 kittens at random, which means we have 8 trials, and we want to know the probability that exactly 5 kittens will sleep no more than 15 hours. We should be thinking binomial, and because we want the probability that exactly 5 kittens, we can either look it up in our table or we can use the formula. So the formula says that we have this random variable y that we know is capital Y, that we know is distributed binomially because we have a certain number of trials, we have a certain number of successes, and we have a constant probability because the probability would always be we'll sleep no more than 15 hours. Okay, so we know y equals 5 because that's the number of successes. We know that the total number of kittens we're choosing from is 8, but we don't know what p is. So how do we figure out p? Well, p, like I said, is the probability that they will sleep no more than 15 hours. Well, the no more than 15 hours is from our normal distribution because that gives us the probability of determining more or less than a certain number of hours. And so the probability is the probability that our normally distributed random variable capital X is less than or equal to 15. Okay. Now we have this normally distributed random variable X, but remember that X is not a standard normal, right? It had a mean of 14 and a sigma that we determined last time was 1.61. So we need to convert to the standard normal. So we do Z of 15, which is our X, minus 14, which is our mu, divided by 1.64, which is our sigma, and we get the probability that Z is less than or equal to 0.61. So now we're given the little z value, and we want to figure out the probability. So we go to our tables again, but this time, because we're looking for little z, we start on the left-hand side, and we find 0.6. Then we need to find the second decimal, so we look up and see that it's 0.01. So now we have the two spots on the chart that we need to have to find their intersection. So we see that if we have a z value of 0.61, then that corresponds to a probability of 0.7291. Excellent. So now we've solved our p, and we can go back to the binomial because we have everything we need to solve this binomial now. We have n, we have y, and we have p. So if we just plug in those numbers, we get that the probability that y is equal to 5, so the probability that exactly 5 kittens will sleep no more than 15 hours is 8 choose 5 times p to the 5 times 1 minus p to the 3. Plug in those numbers, and we find that the final answer we need, the probability that exactly 5 kittens will sleep no more than 15 hours, is 0.2294. So I hope this made sense, and we'll see you all in tutorial this week.